This is an educational video for eye surgeons and viewer discretion is recommended. It is strange that there isn't a single pupil expander for the millions of patients undergoing manual small incision cataract surgery. The B-OCTA is a pupil expander for these children of a lesser god. We started with a survey asking if surgeons would prefer a pupil expansion device for small pupil MSICS and how were surgeons currently managing small pupil in MSICS. A resounding yes, with 81% preferring a pupil expansion device for small pupil MSICS, convinced us of the unmet need. Clearly, there was no preferred method. Surgeons were either not using any device or using sphincterotomy or pupil stretch or iris hooks. We were surprised that 11% were using the B-HEX pupil expander. The B-HEX and B-HEX 2.0 are extremely thin hexagonal devices with notches and flanges in a single plane. Alternate flanges are tucked under the pupil margin to expand the pupil. Unlike other devices, here the iris bends at the notches. The device can be removed through the main incision or even the side port incision. The B-HEX has been successful for pupil expansion in Phaco surgery, but for MSICS, this would not be enough to prolapse a large nucleus into the anterior chamber. However, we were very inspired by its use in MSICS by some surgeons. That defined the unmet need. A large device that can be safely deployed and yet provide a large pupil expansion so as to allow safe prolapse of the nucleus into the anterior chamber during MSICS. The challenges were, while larger devices provide larger expansion, they are unwieldy and can cause trauma. A 10 mm device would provide a 9 mm pupil expansion, but it would be difficult to handle and would cause angle injury. The pupil engagement mechanism would have to be easy and reversible, yet firm enough that the device is not dislodged during nucleus prolapse. With granted patents for a single plane device with notches and flanges and the success of the B-HEX, we were encouraged to use the same principles and material for the new device. But the design required new considerations. A large square or hexagon would have large flanges, which would be difficult to tuck. Size for size, the octagon would have the smallest flanges. That led to the birth of the B-OCTA. The larger octagon would still have relatively smaller flanges to facilitate tucking. For a larger device, the flanges would be further removed to the periphery and would be less accessible. An inward bend to the alternate flanges made them easily accessible. The flanges look like two stubby fingers which engage firmly to the pupil margin, preventing dislodgement during nucleus prolapse. The tabs with holes are for grasping and also identify the flanges that are to be tucked. The B-OCTA also provides a larger expansion on demand by straightening of the bent flanges when the nucleus prolapses to the anterior chamber. That makes it the expandable, extra-large pupil expander. Now, it was time to put our design to test. We gratefully acknowledge the participation of these surgeons during the trial. Their valuable feedback contributed to the improvement of the design and surgical techniques. The internal lip is opened only to 3 mm to keep the anterior chamber formed. The B-OCTA is slid into the anterior chamber with the B-HEX forceps and the trailing part is tucked in. Alternate flanges are then tucked under the pupil margin by holding the tabs with holes. Now the third flange is tucked. As the fourth flange is tucked, we see the large octagonal shape of the expanded pupil. The wide view allows a large capsulorhexis to be fashioned under direct visualization. And now the internal lip is enlarged in preparation for nucleus delivery. The large nucleus is cartwheeled out of the capsular bag and prolapse into the anterior chamber easily. The B-OCTA remains firmly engaged to the iris throughout this step and also during the delivery of the nucleus through the incision. The wide view allows meticulous removal of even the tiniest wisp of lens cortex. Confirmation of IOL implantation into the capsular bag under direct visualization in MSICS is very fulfilling. For removal, the flanges are untucked either using a Sinskey hook or by grasping with the B-HEX forceps. Thereafter, the B-OCTA is simply drawn out of the incision with the B-HEX forceps. Here, the B-OCTA is being inserted through the side port. The thin profile allows passage through very small incisions. The tabs are held with the forceps and the finger-shaped alternate flanges are tucked under the pupil margin. The tabs with holes help identify the flanges that are to be tucked. Once the fourth flange is tucked, the expanded pupil takes a wide octagonal shape. The widely expanded pupil with the B-OCTA permits a large capsular excess. As we can see, a very large and bulky nucleus is cartwheeled and prolapsed into the anterior chamber with ease, and there lies the true value of the B-OCTA. This is a mature cataract with a small pupil. And since the B-OCTA is a large device, we note the large excursion of the flanges as they are tucked. As soon as the first flange is tucked, the rest of the device moves to the periphery. An inaccessible flange may be grasped anywhere and drawn centrally. This moves the entire device centrally, and then it is easier to re-grasp the flange and tuck it. The nucleus appears relatively small because of the large pupil expansion provided by the B-OCTA. Removing this thick calcified cortex was a challenge. It had to be nudged out by stroking the peripheral anterior capsular rim. This wouldn't have been possible without the pupil expansion provided by the B-OCTA. The IOL is comfortably dialed into the capsular bag under direct visualization. The flanges are untucked with the B-HEX forceps and the device is removed from the eye. MSICS is now safer and more predictable with the B-OCTA, the expandable extra-large pupil expander.